you have to find out the height of the pole at this place when a body is projected with a angle of 45 degrees over here. And the pole is at a distance of A from the origin, and from the pole to the point of dropping of a body touching the ground, from here to here distance is taken as B. We need to find out the height of the pole. Okay, so this point, the topmost point of the pole, is considered to be on x-axis. The coordinate system you consider, this distance is going to be A, and this distance is going to be H here. Okay, because on y-axis height is considered to be H, so you can write this as A comma H here. Okay, so now let us see. He's asking us to find the height of the pole here. Try to imagine. You have to imagine what is going to happen. There is a pole, electric pole. Let us imagine you are throwing a body with the horizontal making at an angle of 45 degrees, and the pole is like this, and the ball is crossing the tip of the pole and falling on the other side. A ball is projected at an angle of 45 degrees. It is just moving above without touching the pole and just falling on the other side of the pole. And you just remember one thing, pole is not exactly at the middle here. Pole is a little bit towards the origin. So it is not exactly at the middle, it is little bit towards the origin here. That is a concept. Now, how are you going to do this problem where we need to find out the height of the pole here? It's a very, very simple concept. First of all, you should have some basic knowledge to understand this problem. Okay, let us discuss about the basic concept here. You all know that when a body is at this place, when it is dropped, when a body is at this place, let us imagine x distance. Okay, x, for example, according to this condition, you can consider the bodies at this place. Now, this is, let us discuss, this is going to be x and this is going to be y here. Let us consider this point is going to be the tip of the pole at this place. Now, how are you going to find out here? You know the basic concept is S is equal to ut plus half at square here. S is equal to ut plus at square. Now, what is happening along the x-axis? S is considered to be x here because this distance is x here, and u is considered to be ux, which is considered to be u cos theta, and a is equal to gx, which is equal to 0 because along the x-axis g is not present. So here you will write x is equal to u cos theta into t, because u can be replaced with cos theta, u cos theta into t here, and this part is going to be 0 according to the problem. So we got here x is equal to u cos theta into t plus 0, so no need to take this right part here. Now what is going to happen along the y-axis? The same formula, right? S is equal to ut plus half at square here. But along the y-axis, if you observe, S is going to be considered to be, a displacement is considered to be y over here. And u is considered to be uy, which can be written as u sine theta. And a is considered to be minus g here, because you are throwing a body against the gravitational force. As the body is thrown upwards, a is considered to be minus g here. Got the point now? So let us see what is going to happen here. You just replace s with y, and u is considered to be u sine theta into t. A means minus g, so you can write this as half gt square here. So this is 1 and this is going to be 2 here. And if you substitute here, what are you going to get now? Y is equal to u sine theta into t. So t here, if you consider t is equal to x by u cos theta here, let us this consider to be 1 here. This 1, if you substitute in 2, instead of t you can write this as x by u cos theta, u gets cancelled here, minus half g, and t can be written as x square by u square cos square theta here. So y is equal to sine theta by cos theta is going to be tan theta into x, and this is going to be g by 2u square cos square theta into x square. You can write like this. A small modifications you have to do here. Okay, what are the modifications you are going to do now? Let me discuss here. So what are you going to do now here? You can write this tan theta like that only. You can write like this only, x also same way. But here you can consider this part as 1. Okay, this part you write 1. This g goes to the denominator here. 2 u square cos square theta by g you can write now. So now here in the denominator, you should get the formula for range. And you know the formula for range. Range is nothing but u square sine 2 theta by g. U square sine 2 theta by g means 2 sine theta cos theta by G here. So this formula you have to create at the denominator so that you can write x by r here. So to create that formula, so you are writing y in terms of range. For that, denominator should be a little bit modified so that you get range at the denominator. So what are you going to do now? So you just write x square in the numerator only like this. But here you just take out one cos outside. Cos square, in this cos square theta you take it out cos here. Now you will do one thing. You create one sin theta in the numerator and write one sin theta in the denominator. So sin theta gets cancelled. Cos theta becomes cos square theta. This is the formula, previous formula you are going to create. Now, yes, now you got 2 sin theta cos theta. Here also 2 sin theta cos theta, and u square is also present and g is also present. So now you will get this total formula is considered as a range here. Okay, this sin theta by cos theta is going to be tan theta. So let me write here, this is going to be tan theta into x minus, this can be written as x square, this sin theta and cos theta can be written as tan theta here, x square by this total part is going to be range. Okay, and you can write like this tan theta here. Okay, so this is the formula you're getting now. Okay, so what are you going to do now? Let me write here. So from this you write, from this you can write like this. Here you can write y, x tan theta you can common out here. So you have common out x tan theta at this place. Now you'll be getting 1 minus, okay, so this is 1 here minus, if x is common out, 1x is left here, okay, and this part is going to be r here. So if this is tan theta, this is also tan theta, x tan theta, here also 1x and 1 tan theta is common out. So 1x is left, 1 r is left. So you have just modified this formula. This formula you have modified like this, okay. So whatever the formula you're getting here, this is the basic formula. This formula you are modifying in this way. So what are the basic formula? This is the basic formula which we got previously while proving that the path of the projectile is going to be a parabola. We have proved there. Path of the projectile is a parabola. We have already proved here by using this formula, where you consider this as ax minus bx square you have taken previously, but the same formula you are just modifying so that you can include range in this formula. So it will be very easy for you to understand now. So by doing all these modifications, this is the final formula we got now. And this formula you can use to solve this problem in a very easy manner. So let us solve the problem in a very easy manner now. Okay. So here a body is projected with an angle of 45 degrees, which is just moving over the pole and falling on the other side. From the origin, this is going to be the origin here. You know about that? Origin of this oblique projectile. So from here to the pole distance is a, and from the pole to the other side where the body is dropped, from it is projected, here it is dropped. Okay, so that distance from here to the pole is a, and from here to that point of dropping is taken as b here. So we can use this formula to find out this height of the pole now. How are you going to use this formula? You can write y. Y is equal to x into tan theta 1 minus x by r here. Okay, so you need to find out what is x now. So from this you will understand that x can be considered as a here, because this distance from here to here, x is considered to be a here, and you should know what is range. So from this formula, range is nothing but maximum horizontal distance. A maximum horizontal distance is considered to be the range here. So here to, from here to here, it is going to be range. And range can be considered as the sum of a plus b. Range can be considered as the sum of a plus b. So you can write range as a plus b. That's it. Okay. So just write like this. Here y. And what is y here? So this part height is going to be y here. So instead of y you can write height, because y part is going to be the height of the pole at this place. So you can write h, and this is x. X can be taken as a here, and tan theta is nothing but tan 45, and 1 minus x, x is a, and r is going to be a plus b. That's it. Now what are you going to do here? So h, a, tan 45 is going to be 1. Okay, so it's a simple thing here. You take a plus b as an LCM, and you just here you can write A plus B minus A. That's it. Okay. So here height h can be taken as A, and this A gets cancelled here. You'll be getting B by A plus B here. So height of the pole can be considered as AB by A plus B. Okay. This is the final solution for this problem. I think you understood. So height can be written in terms of A plus B. That is AB by A plus B. This is the formula. Okay. So now, if you understood this, you can just slightly modify this question in a different way here now. So how are you going to write modify this formula now? Let us see. For example, now I think this problem is completed now, and your final answer is h is equal to AB by A plus B here. Okay. So if you understood this one, let us. This is a parabolic path here. In this parabolic path, let us consider during the path of the parabola, at that particular instant, the body is at this place here. Let us imagine the body is thrown making certain angle theta over here. So you have projected a parabola, you projected a body making certain angle theta with the horizontal. Now the body completes a parabola. The body has completed a parabola. Now at this place, if you observe here, let us draw that this point, when you take a straight line from the point of projection to the point of dropping, you join these two lines here. This is going to the point of dropping. Now let us imagine this is going to be the height h here. Okay, so this is going to be height h here. Let us imagine what is going to happen now. So you have considered this angle as alpha and this angle to be the beta. This is the point of dropping here. So this is alpha and this is beta, and this is total angle is considered to be theta here. This is the total angle considered to be theta. Now, for example, any pole is present at this place, and that pole is making on the either sides angle of elevation of that pole. From this side is alpha, from that side is beta. Then you need to show that tan theta is equal to tan alpha plus tan beta. This part you have to show here. Okay. So you need to show that the angle of projection is theta and tan theta is equal to tan alpha plus tan beta. Okay. So this we need to prove here. So for that, what are you going to do now? It's a very simple thing. You can just consider this to be height, and this part you can consider as A, and this part you can consider as B now. Okay. So let us see what are we going to do here. Yes. For solving this, you can consider the same old basic formula which we have derived previously. What is that formula here? That formula is y is equal to tan x tan theta is equal to x tan theta into 1 minus x by r here. This is the formula just now we have derived. By using this formula, you can find out the value of tan theta here. It's very simple to find out. Let us see what is going to happen. Let us see. Here, you just remember one thing, that is tan alpha is going to be opposite side h by adjacent side a, and similarly you can consider tan beta is equal to opposite side h by adjacent side b. So if you remember these formulas here, slowly you can solve the problem in a beautiful way. Now here, what are the parts we need to adjust here? That is y can be considered as h here. Y is considered to be h here. Next, x can be taken as a. X can be taken as a. Tan theta you'll write like that only. But what is range? So range means a plus b as it is as the previous case. So range means the maximum horizontal distance that can be considered as a plus b is going to be the range at this place. So you have taken range as a plus b. Just try to substitute all these things. Let us see what are we going to get now. So y means you are writing h here, and x means you'll write a. Tan theta you'll write as it is. 1 minus x, x is a again. R is going to be a plus b over here. Next, h you'll write. If you want, you can write h here. You take this a to this below h. After that, tan theta part will be like this only, and you can make an LCM. A plus b minus a by a plus b you can write like this. So a gets cancelled. So h plus a is equal to tan theta which can be written as b by a plus b. Slowly you can just modify this formula. This one, what is the next step here? Next step is h by a is equal to tan theta into b by a plus b. So now you can modify this problem like this. So tan theta is equal to, how much you are going to this side? This part you can send to the left side here, h by a into a plus b by b. So tan theta is equal to h by a. This is a by b plus b by b. So b gets cancelled, get 1. So tan theta is equal to h by a. This is a by b plus 1 you will get. So after that, this you can send left side. So tan theta is equal to h by a into a by b plus h by a you are getting. So a gets cancelled here. Tan theta is equal to h by b plus h by a. So therefore you can write tan theta. A by b can be written as, okay, h by b can be written as tan beta here. Plus h by a you can write it as tan alpha. So hence we have proved that tan theta is equal to tan beta plus alpha. Okay, thank you very much. Okay, I think you understood. It's a very simple concept.